So in this video, we'll be talking about simplifying radicals. And so what is a radical? A radical is anything that is a square root, a cube root, things like that, that are being rooted, or in the opposite way, it could be things that are being multiplied by themselves multiple times. And so the simplest way to simplify radicals, I think, is to use the prime factorization method. So here's the steps below how to tackle one of these radical problems, and then we'll go through a few of the practice problems. So the first step is to find the prime factorization of the number. If you don't know what prime factorization is, I encourage you to check out my prime factorization video where we specifically talk about this concept. Step 2 is going to be to determine the index of the radical. So again, for square roots, that's going to be 2, for cube roots 3, and so on. And so then you're going to be able to determine that, and that really depends on if you can actually pull things out of the radical. Step 3 is going to be to move the groups of numbers outside of the radical as appropriate. So let's say you have inside the square root 2 times 2 times 3. You can actually, since 2 times 2 is a group of numbers, you can actually pull them outside of the radical. And lastly, you're going to simplify what's outside and what's inside of the radical just to make it look simpler. I know this might be confusing right now, but we're going to be able to talk about it and go through a couple of practice problems, and it should make a little bit more sense. So to start off, we'll start with a practice problem of the square root of 200. And so step 1 says take what's inside and do the prime factorization of it. So we're just going to pull this over here. Okay, we're going to leave the square root over here, and we're going to say, here's 200. What is the prime factorization of that? So again, prime factorization, we're going to split this up, dividing by the lowest prime, which is 2. And so we'll have 2 times 100. Go ahead and circle the 2. 100 split up is 2 times 50. Circle that. Split up the 50, 2 times 25. Circle that. So then 25, can it be divided by 2? No. 3, no. The next prime would be 5, yes. And so we say that's 5 times 5. So both those are prime. So our prime factorization for 200 here is going to be 2 times 2 times 2 times 5 times 5. And so we can rewrite this radical right here to the right as the radical, or the square root of 2 times 2 times 2 times 5 times 5. So step 2 is going to be to identify the index. So our index here is going to be 2. Let's write this right here. Index is equal to 2. We know that since this is a square root. And so now this makes it easy for us for step 3. Step 3 is going to be to group based on the index and then pull them outside. So we see 2 times 2 times 2. We only can take 2 of those since the index is 2. Right here, 5 times 5. We can take that right there. And so what we can actually do with these, we can just pull them outside as a group. So pull those outside there, pull that outside there. And so now finally our radical is going to look like this. It's going to look like 2 times 5 square root of 2. So basically how we get that is this 2 times 2 just becomes 1, 2, since we're grouping it. This 5 times 5 becomes 1, 5, since we're grouping it. And then this lonesome 2 stays inside the square root. And so finally, step 4 is to simplify this by multiplication. So we have 10 square root 2. And so that's our final answer. And so that's actually equivalent to the square root of 200 up here. And so our next practice problem is going to be using variables. So we're going to do the square root of 25x squared y. And so again, starting out, we're going to do the prime factorization of each of these. So this one, this one, and this one. And again, these are just variables, but they can also be split up. So right here, we'll do 25. Relatively easy. Can't be divided by 2, can't be divided by 3, but can be divided by 5. There you go right there. I'm going to circle those. X squared can be split up into x times x, and then y is just on its lonesome. And so then rewriting this, we know that this is the square root of 5 times 5 times x times x times y. And so again, we know the index to be 2 since it's a square root. Group this, group these, and then just again doing what we did in the last problem, we can now actually pull these out. And so we can say that 5 times x times the square root of y. And so our final answer will be 5x square root y. And so that's going to be our final answer. And that's the simplification of this radical right here. One final practice problem is going to be the cube root of 152x y. And so again, doing this by parts, we'll start with 152. So this is going to be 2 times 76, 2 times 38, and then 38 is going to be 2 times 19, which 19 is prime, so we're done. And so now this can actually be rewritten up here as the cube root of 2 times 2 times 2 times 19 times x times y. And so now since we know the index is 3, right? We're looking for groups of 3. Just so happens we have a group of 3 here. So there's your group of 3. And so now doing the exact same thing as last problem, we can actually pull that outside. And so that's going to be 2 cube root of 19xy. So that'll be our final answer for this one. And as you can see, it's relatively similar to the last problem. The only difference is instead of groups of 2, we're looking for groups of 3. If you have any questions, please drop them below in the comments, and also in the comments suggest any other things you'd like to see. Thanks.